everybody today who is at home quarantining. Today we will be working on practice problems for kinetic and potential energy and reviewing the Coaster Creator Lab that we did last week. So your week at home looks like this. You'll be doing the What Hurt Worse activity today with me. If you're absent, you're going to click here and follow the links on the agenda. We are doing a Bluekit review that I also have linked on the agenda. Every day in the afternoon, I will link my new tutorial video for the next day. So for tomorrow's tutorial video about the lab, I'll do it today after school. So just wait until Monday after school and you'll see the next day's video. Your homework tonight is to finish this What Hurts Worse activity and submit it. It's worth 12 points and it is based on correctness. So make sure you have a calculator with you and that you're not just guessing. If you did Coaster Creators last week and you were in school for that, here's how you got the maximum value if you wanted to be the top scorer. You needed to have the most potential energy, so you had to have the most mass. So you needed 7 carts, and then you need plenty of up and down hills and many loops at the end before it reached the station. Hopefully, whenever you were doing your Coaster Creators for the law of conservation of energy, the last question, you saw that no matter what 2 spots that you put your cursor after the first hill, the total potential dissipated and kinetic energy were equal. And that holds true to the law of conservation of energy. So your 2 values for these 2 spots should have been very, very similar. We now know that there are 2 large forms of energy, potential or kinetic energy. Potential is stored energy and kinetic is moving energy. But before we get started with today's class, I wanted to go ahead and review that. So we are looking at this picture and looking at all the different forms. And we have like electrical energy here as a person talking. We have kinetic energy as the person behind him falls in. We have sound energy because that probably made a splash. We have gravitational potential energy right here where the man is standing high above the dock when he's not paying attention, gravitational potential. There are plenty of forms, and we wanted to review that by playing this Bluekit. Again, if you're at home, you can go ahead and click on the agenda, and that is right here at this Bluekit review, and you can go ahead and play that Bluekit review game. Today we're going to be doing this activity called What Hurts Worse. And how we're going to do this is you're going to click on, again, back into the agenda, you're going to click on the What Hurts Worse, and it's going to take you to a Google form. This Google form is more or less a Google quiz, okay? So it says decide which object will hurt worse if it hits you. Something that's traveling from you're going to travel from station to station, but if you're home, you'll just do this individually. You'll read the situation closely and calculate which object has the most kinetic energy. If it has the most kinetic energy, it will hurt the worst. So show your work on page 12 in your packet, and if you don't have your packet at home for some reason, just use a piece of paper. The final station will have to do with speed limits, and you'll have to make a conclusion as to why speed limits are recommended by the Department of Transportation. Today for the lab, you have to understand that kinetic energy is measured in joules, and kinetic energy is equal to 1/2 mass times the velocity squared. The mass of the object are on the sheets that is linked, and again, that is linked on the side, on this slideshow right here, the mass reference sheet, and you can find that also on the Google form. So you're going to use we talk about weight in pounds, but most people everywhere else around the world use kilograms. So you're actually going to use the column for kilograms. So here's our first situation. Make sure you put your email address and name in. Decide which object hurts the worst. We have a golf ball, which is hit at 40 miles per hour, or a ping pong ball hit at 181, or a paintball at 105 miles per hour. So how do we do this? We take each one of these situations and we are going to do the math for it. And whatever has the most energy will be the one that would hurt the most. So I'll do this first one with you guys. So here's the situations. Oh, okay, for the first one, so it's 1/2 0.5 times the mass. So we need to go find the mass of the golf ball. You'll link back to the data sheet. Golf ball is, this is the weight. So 0.5 times that number. And then we're going to multiply that by the velocity, which is 17.88, and we are going to square that. Alright, so let me pause this for a second. I'm going to go to the next. Okay, so the first one is the golf ball hit at 40 miles per hour will be 7.337 joules of energy. And that's kinetic energy. So let's do the ping pong ball at 181 miles per hour. Ping pong ball, we look at the reference sheet, and the ping pong ball is very, very light. Ping pong ball, and that is, we're going to multiply that by the velocity, times the velocity, 80.31, and that's meters per second. We're going to square that. Okay, so an easy way to do this is if you just take this, if you don't have your calculator handy, you can take this equation that I just wrote out, and we can put it into Google. Okay, and we put an equal sign so they know to calculate it, and we paste it, and the Shift S turns it into a power sign. And you square it. Alright, so that is 8.3 joules of energy. Now the last one, we have a paintball at 205 miles per hour. Now the paintball, I know, it's a little bit heavier, so a paintball, this is what I would guess would be the most. Paintball times, and that is 91.64. We're going to square that. Oh. So that was only 4 joules of energy. So the one that has the highest amount would be the ping pong ball hit at 181 miles per hour. Since it has the most energy, that would be the one that hurts the most. So when we go back to our form, we would hit our ping pong ball, and then we move on to our next problem. Okay, this one is a cricket ball or the jaw ball thrown, and you just continue. Each one of these were 3 points apiece, and you would then at the end make sure you take some time when you answer this final question, and hopefully you understand this then about the speed limit, how much more energy it creates. All right. If you need help, I will be available after school from 2 to 3:20, but please try to follow the agenda when doing your work this week.